Hello once more. Welcome to this lesson on SI petrol fuel systems, and today we want to be talking about fuel pumps. So previously we talked about the fuel supply system of the petrol engine, and we looked at the various components that make up a fuel supply system, and then we agreed that how we lay out these systems will give us different various designs according to application. So we looked at various layouts. We looked at the gravity feed and the pressure feed, and then we started talking about the components that make up each of these fuel supply systems. Now we mentioned about the tank, the fuel lines, and the fuel filter. And today I want to talk about the fuel pumps. So why do we need a fuel pump in the first case? Now we agreed that in the layout, when you position the fuel tank below the level of the carburetor, allows forgive me for this error here, but I wanted to mean about when you position the fuel tank below the level of the carburetor, then there is a need to devise a mechanism to draw fuel from the tank and deliver it to the carburetor. Similarly, if you use injection systems, there is also a need even to use a bigger pump to draw fuel and raise its pressure well above 3 bars for effective atomization by the injectors. Now, in this case, there are two types of pumps used. There is a mechanical pump and there is the electric pump. Now, the electric pump may also have an older solenoid type of pump, or we could have an immersed pump that uses a roller cage mechanism, which we're going to see much later. Now, let us look at this mechanical pump with this image here. That is a sectional image. We'll use it to explain the construction and also how it operates. Now, this pump, we said, is suited for carbureted systems, and the pump is made from aluminium that has been cast through a die. So the aluminium alloy pump is made from two sections, separated by this green line here, which is actually the diaphragm. So the upper part will have the pumping chamber right here. We'll have the inlet valve on this left and the outlet valve on the right. And then we have a fuel inlet on the extreme left where fuel passes up into the dome above here. The fuel passes through a filter and is collected here, awaiting for the next command. The fuel, once it's inside the pumping chamber, is then compressed by a return spring or the spring here, which pushes the diaphragm up to reduce the volume of the chamber and expel the fuel outside past the exhaust valve and then out through the fuel outlet. Now the lower part of the pump consists of which is, we said, is separated by the diaphragm. We'll have the diaphragm spindle, which secures the diaphragm through several plates, 2 plates here, and then below it we have a coil spring. The coil spring makes sure that the diaphragm is always retracted back up to the maximum position. The diaphragm spindle is connected to a link. This link here is in 2 parts. The left part of it is called the link assembly, and the right part is calling it the bell crank lever. The two are conjoined here by this pivot. The bell crank lever sits on the return spring. The return spring makes sure that the bell crank lever is always pushed outwards to make sure that it rides on the camshaft. Now this is a camshaft that is driven by the engine at half the engine speed, and this camshaft has a lobe that pushes the bell crank lever in and out, and and that action is what is transferred to the link assembly, then pulling the diaphragm up and down. Now, having looked at this construction, we can go ahead and look at how it operates. We say that this pump is operated by the engine as it runs, and I want to use that image to demonstrate how this pump works. Let me use this image. I will draw some marks here just to show that this rotates round in that direction, and this causes the bell crank lever to move in those two directions, and here in this direction. So the bell crank lever can move left and left, and this causes this link assembly, it is pulled downwards. There. So as the engine rotates, it rotates with it the camshaft here. This camshaft then causes the bell crank lever to move in and out, and that mechanism is relayed to the link assembly on this face here. These are two links, one on the left and the other on the right, and this forces this link to move downwards, and that pulls the diaphragm spindle against the spring tension to pull this elastic member, they call it the diaphragm, downwards. This has the effect of increasing the volume of the pumping chamber, and when we increase this volume, we create an area of depression, which you said is an area that has a pressure lower than atmospheric pressure. Now, if this area has a lower pressure than atmospheric pressure, and the fuel tank is exposed to atmospheric pressure, that will cause fuel to flow from the tank through the fuel lines, through a fuel filter, and up into the fuel to the fuel inlet and into the fuel chamber, where a filter here removes any impurities, and this depression will cause this valve here to open downwards against this spring, allowing fuel to fill the pumping chamber. Now, as the camshaft continues to flow out and the lobe moves away, the bell crank lever follows it, leaving a gap here. The gap here will allow the diaphragm spindle to retract backwards through spring tension, and that causes the diaphragm to move upwards and reduce the volume of the pumping chamber. Now, because this valve, its seat is blocking this outward way, petrol cannot flow back out through the inlet, but the position of the outlet valve has its seat sitting down, facing downwards, so any pressure that is increasing here above atmospheric pressure will cause this valve to open upwards and allow fuel to go out to be delivered to the carburetor. And this action repeats itself until the carburetor fills up. So when the carburetor fills up, a valve inside the carburetor called a float valve shuts off the supply of fuel to the carburetor, and that means that the fuel in the line is backed up all the way into the filters and into the pumping chamber. So during this time when the pump has filled up, because the engine will not stop running, the eccentric shaft keeps rotating round and round, and that pushes the valve in and the bell crank lever in and out against the spring tension. But here we have a separation between the link assembly and the bell crank lever. So once the eccentric pushes the link downwards and it pulls down the spindle together with the diaphragm against the spring tension, that will increase the volume of the pumping chamber and draw fuel inside the pumping chamber. Once the bell crank lever moves away, the link assembly will try to retract against spring tension to push fuel outwards. But remember, we said inside the carburetor that there is a float valve that has stopped any flow of fuel, meaning that this fuel cannot leave the pump. It cannot flow backwards and neither can it flow forward. That means that the pressure inside here remains as a constant, holding the diaphragm downwards together with its link assembly. Now, because these two are separated, it means that the new position that the link assembly will take will be slightly skewed here. So I'll try and draw my link assembly here, ensure that my link assembly will be in that position now, drawn back downwards, somewhere there. So there will be a gap left in between here because the link is being held downwards by fuel pressure, and this gap will allow the bell crank lever to keep moving up and down, idling without necessarily supplying fuel to the tank. This remains in the status quo until the fuel in the carburetor is consumed, allowing now for the fuel in the pumping chamber to be evacuated to go to the carburetor and the link assembly together with the diaphragm spring to move back outwards with the diaphragm to reduce the pumping chamber. And then these two will come into contact again, and the diaphragm and the eccentric can push the bell crank lever and pull the diaphragm down to allow for fuel to be drawn in again. And that also continues to and fro to make sure that fuel is applied continuously to the engine. I'd like for you to take a look at it again, and next we shall be talking about the electric fuel pump. Thank you.